Okay, we might make a start, and I'd really like to welcome you all to the first of our invited sessions for ISSLS this year. And it is my great pleasure to introduce our invited speaker, Professor Nadine Foster. Nadine is a physiotherapist who has recently, well, mid-COVID, arrived in Australia from the United Kingdom and is now the Professor and Director of the STARS Education and Research Alliance, which is a collaboration between the University of Queensland and Metro North. And her role is a really innovative role, trying to encourage collaboration between health service and education, and it is a challenging role and one that she's embracing. And what Nadine has done for her career has been research investigating and developing new ways of delivering health service, particularly related to musculoskeletal conditions like back pain and osteoarthritis. And some of her work has been pivotal in development of projects such as StartBack, which I'm sure many of you are familiar with. Nadine has undertaken many clinical trials. She's been either the lead or collaborator on 28 large clinical trials. And today she's going to talk to us about trying to consider some innovation in the way that we do clinical trials. And it's my great pleasure to invite her to give the invited lecture.
Thank you, and thank you for the kind invitation to come and talk a little bit about innovation. And I'm going to focus on randomised controlled trials. I'd first also like to acknowledge the traditional owners and custodians of the land on which this conference is taking place and pay my respect to elders past, present and future. So to give you a brief overview, I'm going to cover sort of 4 things within this presentation. One is I'm going to sort of go back a little bit for some of us to understand again why the randomised controlled trial is an important tool in our toolkit of scientific methods. I'm going to bring that forward then into thinking about where we're at in terms of randomised controlled trials in back pain and spine, and I've used both of those terms in various PubMed searches that I'll draw on throughout the talk. Understanding, of course, that whether we're talking about a symptom or spinal disease and spinal conditions, that all of that is relevant for this presentation. I'm going to highlight some of the innovations that I believe are in play and that we're already in the thick of, as well as those that are coming. And by innovations, I'm simply thinking about new ideas that create value. But I also want to highlight some things that I think are game changers. And for those, I'm talking about new ideas that create a profound break with previous patterns. And hopefully then, by the end of this presentation, we'll all be thinking a little bit more collectively about the way that we're doing randomised controlled trials in the field. So let's just, again, look at the randomised controlled trial. And you'll all feel familiar with this, I'm sure. It's a research study that randomly allocates participants to compare 2 or more treatments, interventions, to find out which is more effective. And of course, those treatments could be anything. They could be medications, injections, surgeries or procedures, devices or therapies. The interventions could even be complex packages of care, models of care, or indeed whole health service changes. But the crucial thing about the design, of course, is that we sample from the population, we randomly allocate patients to 2 or more treatment groups. One group get an intervention of interest and we measure the outcome, and then the other group get a comparison and we measure the outcome. And we think carefully about the comparison. It might be to address a question like, does this treatment work? And we might choose a placebo control. It might be to answer a question like, well, does this treatment offer anything better than usual practice? In which case we might choose a usual care control. Or we might set a higher bar, as we might say, and we might really test the new intervention to demonstrate superiority over something like the best available alternative treatment. And those decisions are all in that design phase of these randomised trials. But let's just, again, dwell in why the randomised controlled trial is an important design. And it really is about the logic of experimentation. Because these trials answer a basic question does allocation of treatment A rather than treatment B cause a difference in that outcome variable? And that can only be confidently answered if other potential causes of a difference in outcome are held constant. And so we have our trial design. Patients are randomized to treatment A or treatment B. We will have collected baseline data, and the groups will differ only in terms of the treatment received, and that's the intervention variable. And then we'll prospectively follow patients up and we'll measure our outcome, and the groups will differ in the mean scores on that outcome variable. And the difference between groups on the outcome variable can be attributed to the difference on the intervention variable. And that's all because of this protected comparison. And the treatment groups must not differ systematically at the outset, so we have to achieve baseline comparability. And the treatment groups must be treated identically during the trial, except in respect of that intervention variable. And it's through this design, therefore, with this protected comparison, that we can confidently draw conclusions about the effectiveness of an intervention. So we sample from the population, we allocate to intervention A and intervention B, and the protected comparison is there because of randomization. Because only through randomization are we randomly allocating patients in a way where we balance both known and unknown confounders and can draw conclusions that include causation. So it's randomization. The allocation of members of the sample to the treatment groups in the trial is determined by chance, and the probability of allocation of any participant is normally equal for each group using a 1-to-1 randomization ratio. And the expected value of any between-group differences, therefore, in any variable is 0. So it ensures that the values of outcome variables and of possible confounding variables are comparable across the arms of the trial. And it is only on this basis that differences in the outcome variable can be attributed to the intervention variable. So all of this explains why the randomized control trial sits quite high in the hierarchy of evidence when we're talking about the comparative effectiveness or effectiveness of treatments. But this equalizing effect, this protected comparison, is greatest when the sample is large and when the sample is relatively homogeneous. So large trials do this better than small trials. I'd also just like to mention equipoise, because of course the randomized control trial is a good design when there is equipoise. So at the outset, there should be genuine uncertainty of the relative effectiveness of the treatments being compared, because without equipoise, the trial may be ethically unjustifiable. But I want to stress the point, of course, that RCTs are suitable when there is collective equipoise or uncertainty. So we are uncertain as a community of whether treatment A is better than treatment B, even though, of course, we know that within the community of clinicians, there will be individuals who are not at all in equipoise. But the randomized control trial is the appropriate design when there's collective uncertainty. This type of design has been around for a long time. It dates way back to 1747 to James Lind, who was a Scottish naval surgeon aboard a ship where he was trying to treat scurvy in his sailors. And it wasn't until probably the 1940s before the first published randomized control trials started to come forth. It's now considered by many to be the gold standard method to compare treatments and test treatment effectiveness. And that's because of some of the things that I've been covering. It's least likely to mislead us if it's done well. It controls random error, and that works particularly well when there's large numbers. And sadly, even small randomized control trials, therefore, cannot discriminate between small differences. It's also least likely to mislead us because it carefully controls bias. And that's about recruiting many. It's about that randomization, ensuring the value of the outcome variables and possible confounders are indeed comparable. If we can build in blinding, then that will help further reduce bias. We'll carefully consider our comparison group. We will conduct an analysis by allocated treatment, or as I say, we analyze as we randomize. And all of these features together mean that we can draw inferences about the outcome variable being attributed to the intervention variable. And no case series and no cohort study, even though they will be useful to ask and answer other questions, no case series and no cohort study can do this amazing thing because of this randomization and protected comparison. So let's bring that forward a little bit to randomized controlled trials in the field of back pain and spine. I did a little look at PubMed as I was preparing for this presentation, and PubMed, of course, is a wonderful resource that has lots of information about published research, and you can filter on certain search terms and so on. And so I took the terms very broadly in green back pain and in blue spine, and since the beginning of time, if you like, in terms of PubMed, as of the 30th of April, there were 5,597 randomized trial hits on PubMed when I searched for back pain, and 8,279 hits when I searched for spine. And if we break that down in chunks of time, it starts in 1968, and in the first 20 years after that, there were relatively few of these things, very few randomized controlled trials, only 129 in back pain and 171 in spine. The next 20 years showed an explosion of activity in randomized controlled trials, jumping up to 1,800 in back pain and 3,400 in spine. And we're continuing on that upward trajectory in the last 13 years, 3,583 in back pain, 4,624 in spine. And it would be fair to say that given that volume of randomized controlled trial evidence, you would expect that we were pretty certain about what we should be doing in clinical practice. But the sad reality is that despite that volume of randomized controlled trial evidence, much of what we're doing in clinical practice is still based on either no trials at all, low quality trials, or inadequate trial evidence. And you see systematic review after systematic review, especially those that judge the quality of the included trials, saying that they're really insufficient quality or low quality. And I thought I would just draw, for example, on the Lancet Low Back Pain series that was published in 2018, where we had the opportunity to look across several internationally recently published clinical guidelines where they had done evidence reviews. And at that stage, at least, take a deep dive into the evidence so far on prevention and treatment of low back pain. And we drew the conclusion that much of modern back pain care appears ineffective, or it's based on insufficient evidence and/or is harmful. And over the next few slides, what I'd like to do is just summarize some of the things that we found as part of the Lancet series work. But what I'd like you in particular to look at is the amount of red on the slides, because I'm using the red color to indicate where the evidence was insufficient. So let's take a closer look. Prevention of low back pain is really under-researched. There's a lot of red on this slide, particularly in children, where there's virtually no evidence how to prevent low back pain in children and adolescents. But even in adults, the research that is available is mostly low or very low quality. When we move into the very basics of education and self-care, we begin to see red in terms of some of the treatment options that are available to us. When we think about non-pharmacological therapy, we see red of insufficient evidence around some commonly used non-pharmacological therapies. And the same is true for medications such as muscle relaxants and antidepressants. And the same is true for invasive treatments with insufficient evidence for things like discectomy, laminectomy, and spinal fusion. And that led me to be thinking about the idea of research waste. And there's been quite a bit of interest in research waste in a broad sense, not specifically only with trials. But Ian Chalmers and Paul Glasgow wrote a lovely paper in 2009 about avoidable waste in the production and reporting of research evidence. And the Lancet has really taken that forward. And in 2014, they published a whole series of studies that were all focusing on increasing value and reducing waste in research. And if you'll bear with me, what I'd like to do is just highlight some of these 4 key pillars, if you like, of areas of research waste that they highlighted. The first, of course, is the question itself. Are we asking the right questions in our trials? are the questions relevant to clinicians and patients? And they identified a pervasive challenge of low priority questions being addressed, of important outcomes not being included, and of clinicians and patients crucially not being involved in setting the research priorities that then provided the background justification for the randomized trial. If we move forward into that second pillar, they focused very much on the design and methods, where they said that over 50% of studies are designed without reference to systematic reviews of existing evidence. So getting on and getting a trial funded and getting on and conducting it without really taking a deep dive into what does the available evidence already say so far, and how does this new trial add anything. They also found that over 50% of studies fail to take adequate steps to reduce biases, and in particular, a problem with unconcealed treatment allocation. So again, that beauty of the protected comparison of the randomized control trial being completely undermined if the allocation to treatment arms is not concealed. The third pillar focused on accessibility of the information, where they highlighted that over 50% of trials are never published in full. And of course, we as people who sit on editorial panels or review other people's papers for publication have a responsibility to think about that as we're making our decisions about whether to recommend publication or otherwise. It is still, unfortunately, the case that it's much more likely that a positive trial will be published than a negative trial, misleading us all in the field of back pain and spine. They highlighted also the biased underreporting of studies with disappointing results. And then finally, they drew attention to the way in which we report our randomized trials, with over 30% of trial interventions not sufficiently described, over 50% of planned study outcomes not reported, so a highly selective approach to the way in which we report our trials, presenting perhaps the outcomes that we find more interesting or that we would like to tell the world, and not reporting the outcomes, for example, that didn't show superiority. And then finally, to close the full loop again, most new research not interpreted in the context of systematic assessment of other relevant evidence. Because after all, one trial is only one trial, and in the ideal world, we have many trials to close the clinical uncertainty for practice. So what I want to do is just drive this home a little bit into our own community of back pain and spine. And I'm coming back to this graph again. And I'm going to highlight 3 common examples. And I've tried to choose common examples across relevant fields for us all. The first is medications for acute low back pain. So we know absolutely that if you have an acute episode of low back pain and you go and see your GP, the vast majority of people will leave with a prescription for medication. And it depends on the study and it depends on the healthcare system, but probably between 60 and 80% of people will leave with a medication prescription. Another really common treatment is exercise for chronic low back pain. And of course, we've seen that become even more common given that this treatment is recommended universally in international guidelines for chronic low back pain. And then the third one, I've tried to pick a surgical example, which is relatively common for surgery, and that would be fusion for lumbar degenerative spine. So let's take a look at the analgesic medicines for acute low back pain. And there's been a lovely paper published just recently in the BMJ, which is a systematic review and network meta-analysis that has tried to compare the effectiveness and safety of the sea of analgesic medicines that are available for adults with acute non-specific low back pain. Despite how common this treatment is, there are only 98 randomized controlled trials with 15,000 patients comparing 69 different medications or their combinations, and most of those were compared to placebo. So most of these trials ask, does this treatment work? Not, is this treatment better than an alternative medication? There was considerable uncertainty, and data were very low confidence in 87% of 741 comparisons. So this was a Herculean piece of research for the team. And in the end, what they recommended was a cautious approach to the use of analgesic medicines and higher quality randomized controlled trials, particularly of head-to-head comparisons, being needed. Let's look at exercise for chronic low back pain, and I'll draw on, of course, Jill Hayden's amazing work in this field of gathering in the evidence internationally for exercise for chronic low back pain. The first Cochrane review that she led was in 2005, and the most recent update was published in 2021. And partly an explanation for the length of time it took for this update to reach its endpoint is the sheer volume of randomized controlled trials in this field, with 249 randomized controlled trials, but an average sample size of 98. And so even if you assume that most of those trials have two parallel arms, that means less than 50 patients per arm in most of these trials. Small trials unable to detect small or moderate between group differences. 151 of those trials compared exercise type A versus exercise type B, and 142 trials compared exercise versus a non-exercise comparison. And the reason why that doesn't add up to 249 is that, of course, some of the trials had more than two arms and had more than one comparison. The key messages from this, and I want you to think about the words being used: exercise probably reduces pain compared to no treatment and so on. Exercise may reduce pain and improve disability compared to, and so on. And finally, there is a lot of research in the field, but we need bigger and better designed studies to allow us to draw firm conclusions. And indeed, Jill and her team went on to actually say this field is saturated with small exercise trials, many of which suffer from poor planning, poor conduct, and reporting due to limited resources. And then finally, the third example, let's move to lumbar fusion surgery for chronic, severe low back pain in the presence of degenerative spine disease. And the most recent systematic review, but of course there are more reviews on this topic than there are empirical trials, was published in 2021, where they did a meta-analysis on function outcome using the Oswestry Disability Index. And even though there are 6 randomized controlled trials, they could only pool 3 trials in the short-term analysis with outcomes up to 2 years, and that only included in total across those 3 trials 159 patients. And in the longer-term follow-up of more than 2 years, they were able to pool data on 675 patients, including 4 trials of the 6 available. And you can see the diamond, which of course is the pooled estimate, that crosses the line of no difference between fusion surgery and non-operative treatment, but tantalizingly sits in the left-hand space, suggesting some modest benefit of fusion surgery overall. And that indeed was what this systematic review concluded, that fusion surgery is no better than non-operative treatment, but there is inconsistency in the results. And they argued that studies with larger samples and higher quality are needed. So let's think then about the game changers. So this is where we're at in terms of the back pain and spine field, a sea of randomized controlled trials, many of which are not adding value. And I'd like to argue that there has been a few game-changing new ways of working already in the field that are creating a profound break with those previous patterns. One is the large-scale, simple randomized controlled trial. Not that any randomized controlled trial is simple, but I'm talking about simplicity of design. These are what I would call mega trials. And they ask the question, is this treatment helpful on average for a wide range of patients? They recruit patients from many centers. They have a relatively simple design. And the key thing is they collect 10 times less data and recruit 10 times more patients. And in my career as a physiotherapist and clinical researcher, these game changers have definitely come along. And I'm just going to highlight a couple that I consider to be game-changing trials. One is an older one, was published in 2004, and it was called UK Beam. And it was a trial of over 1,000 patients in general practice with many general practices, many sites, and it included several arms of conservative care interventions like exercise and manual therapy, and wanted to tease out if these therapies were more beneficial than usual GP care. That trial was a Herculean trial at the time to land, deliver, fund. It needed an extension from the funder in order to reach its endpoint. But when it was published, it was a game changer in the UK, because here was one of the first really large mega trials, simple design, but clearly answering the question it set with very high accuracy. So narrow confidence intervals, robust estimates, it answered the question. Another example is a more modern trial published in 2014 in the field of medications for acute low back pain. This was the PACE trial from Australia. Again, a mega trial, 1,652 patients. It had 3 arms, and it compared different ways of delivering paracetamol, either regularly or as needed, versus a placebo control. And again, the beauty of this trial is the way in which it answered the question. So it set a clear question, and it delivered a mega simple trial and answered that question with a high degree of precision. So not much uncertainty in these types of trials when you get to the end point. The other thing about these which makes them game changers is that these trials have serious impact. These are the trials that are picked up by guideline committees. These are the types of trials that are then informing all of our clinical practice. They're game-changing trials. But I'd also like to highlight another game changer, and that's more about the way in which we do trials. So I'll give away my age. I've been doing research for 30 years, and like many clinicians, I started my clinical career thinking about the questions that I had about my practice and wondering, about whether I could design and do clinical trials like the interested clinician that I was, questioning my practice, questioning physiotherapy practice, and wanting answers that I felt were needed to underpin what I was doing. And so the lone trialist or the interested clinician model of randomized control trials was certainly alive and well when I started my career. And like many people, I jumped out of the airplane without really knowing too much of what I was doing in those first few years of dabbling in clinical trials, doing small, underpowered, single-center trials like many people do. And then I learned a little bit, and I thought, well, maybe I ought to work with people who know what they're doing, and maybe I find a mentor or someone who's done one of these things before. And a really nice example of that picture, perhaps, is the PhD student who does a randomized control trial for their PhD, and they have a supervisor who's done a few trials before. And truly, that model of doing randomized clinical trials has more or less died in the UK because of the risks associated with delivering a high-quality trial in that way. And so another big game changer, certainly in my career, has been the move towards large trial teams with expert methodologists, trial managers, and clinicians, all working together in a connected, supportive team with complementary knowledge and skills, and in that way being able to do these really impactful trials that are game changers. I want to just draw an example in surgery because I think there's really interesting things happening internationally in the surgical trial field. This review, Research Waste in Surgical RCTs, wasn't specific to spine, but they found that 85% of 304 randomized trials demonstrated at least one feature of research waste that I mentioned. And they even went as far as to try to work out what the odds were, depending on different characteristics of the trials, as to whether they'd be less likely to be associated with research waste. I'd love a bit of audience participation. I don't know whether you can guess what the features of the trials were, where they were least likely to demonstrate research waste. And I found 2. So those trials that were multi-center and those trials that had external funding were the trials in surgery which were less associated with research waste. And you might argue, well, that's, it's hard to get external funding, it's hard to get multi-center trials up and running and to get them delivered. And I'd agree with you, it is hard. But there's something about these processes of submitting protocols for peer review and sharing protocols with colleagues across multiple sites that then through, if you like, team science, they're improved and polished. That means that these trials are higher quality and less wasteful. In terms of innovations in the surgical field, I'd draw your attention to some amazing things that are happening in the UK at the moment around the Royal College of Surgeons' Surgical Trials Initiative, where they've invested strategically in a small number of clinical trials units that have, over the past few years, become surgical randomized control trial centres of excellence, training the next generation of particularly surgical trial leaders. And an amazing initiative around trainee-led surgical research collaboratives, where trainees are working together in national connected trials, supporting the recruitment at many sites, and in turn getting trained in clinical trials, and something called the NIHR Associate Investigator Scheme, where their input on those trials is highly recognised. And then a third example, the IDEAL framework. If you're a surgeon and you haven't heard of this, I would recommend you take a look at it. Because there's a whole series of papers now around the IDEAL framework to help guide and improve the quality of surgical trials. This one that I've put on the slide is particularly focused on randomized trials. So I've talked a little bit then about these game changers, these simple mega trials, the way in which we do trials, and the way that we're moving towards greater team science in trials. But of course, there are many other innovations, and I thought I would just highlight some of them using this slide. At the top where we'll start, I'd like to highlight the innovations in patient and consumer involvement in prioritising the questions. I'll give you just one example. I mentioned James Lind, of course, in the historical story of the randomised trial. But in the UK, there's something called the James Lind Priority Setting Partnership, where collectively there's now a very standardised process to bring consumers, patients, clinicians, and others together to ask important questions in certain areas. I took a look at the website just recently, and they have a scoliosis priority setting partnership, where together these groups have identified 54 unanswered questions in scoliosis, and together come up with the 12 top priorities for research. And the innovation of this type of work is that then, of course, what happens is that the funders that fund scoliosis research then start to nudge the research community to start to close the gaps on those priorities. And in that way, the pendulum swings a little bit away from researcher-led research and much more to the research questions that the community need answering. So the power of patient and consumer involvement in research is innovating the field and will continue to do so across the world, in my opinion. Another innovation, of course, is in the greater use of pilot and feasibility randomised control trials. I had a look back in PubMed to see when did the pilot trial thing start, because in those early 20 years, there were very little pilot randomised control trials published. So it seems to be a relatively new thing, the whole idea of a pilot and feasibility trial. And then more recently, the move to the internal randomised control trial pilot phase. So instead of the inefficiency of doing an external pilot phase, closing that down, analysing the results, then suggesting a new big main trial is needed, and then going through the whole processes of starting up a trial again, getting it funded. The idea that we might build in internal trial phases into these big trials, but we can pre-specify some clear stop, amend, go criteria upon which the progression to the main trial phase is linked. Again, in my career, that has really changed the landscape. In the UK, it's almost impossible to get a big main multi-centre randomised control trial funded anymore unless you have either an external pilot or an internal pilot phase. And that little figure, if you can see it, which starts at 1979, is the rise of the pilot trial, as I call it. And you see, of course, just how popular they've become as people understand that it's much better to test things out first before investing in the time and money and collective effort in doing that large definitive trial. As well as the IDEAL guidance, there's so much great guidance now for randomised controlled trials out there. There really is little excuse anymore for writing a randomised controlled trial protocol that is poor quality. Again, the SPIRIT guidance has changed the landscape. How do we write a really good protocol? Well, have a look at the SPIRIT guidance. It will tell you exactly how to write a really good randomised controlled trial protocol. But it doesn't stop there. What about outcomes and reporting? We have core outcome sets that are internationally agreed. Let's use them. If you haven't heard of something called the Equator Network, I'd really recommend you simply Google it and take a look. There's over 200 guidance documents where methodologists from around the world have spent their time providing guidance on almost every aspect of randomized controlled trials one can think of, whether it's a trial of surgery or exercise, a drug trial, a trial of acupuncture, a crossover trial, a cluster trial, a factorial trial, a stepped wedge trial. Goodness, I could keep going. The Equator Network has all of that guidance on it, free to access. Another, another little graph to show, and I've underlined that this little graph from 1968 to 2023 is the rise of the RCT protocol. So, of course, when I started my career, it was pretty unusual to be publishing a protocol for your randomized controlled trial. So not only now are you expected to register your randomized controlled trial in international registries, but you're expected to publish a full and detailed protocol to guard against things like selective reporting as you write then the results paper. And you can see it clearly in that graph, the rise of the innovation of publishing randomized controlled trial protocols. A further innovation, of course, then, as we've moved to mega trials, is more multi-site, multi-country, larger randomized controlled trials. And that can be for various reasons. It might be because it's a relatively rare condition, and of course in spine there are plenty of relatively rare presentations where we likely need multinational collaboration. But it might also be a really important way of harmonizing data across trials that then run to the same protocol, but in different countries, in different healthcare systems. And with the idea of pre-specifying plans to pool data in the future to do all of the interesting moderator analysis that we all know that it desperately needed in the field. And we see amazing now opportunities funded by the UK, Canada, Australia, and others that are kind of incentivizing us as clinical researchers to head towards multinational collaboration. Another innovation is that more data sharing, randomized controlled trial banks and IPD, individual patient data, sharing and meta-analysis. I've been involved in about 4 IPD meta-analyses projects, and that's been a really interesting process that I'd be happy to talk to anyone about, which raises all sorts of really interesting concerns about data integrity and trial integrity as you go asking the international community, would they be willing to share their trial data set? Knowing that the first thing you're going to do with it is rerun their analyses and see if you can replicate the results that they published. But as we move towards all of this, it's going to drive up quality and drive up transparency and drive up access to the data. No longer will it only be the CI's data in their cupboard or in their computer. It'll sit on publicly accessible data sharing websites and be able to be subjected to further analyses. And the last one on this slide I'm just going to mention a little bit about, because many of you may be very unfamiliar with the benefits of qualitative research or social science methods in trials. But I think they have a lot to offer as we innovate the business of doing these trials, either before randomized trials or indeed during randomized controlled trials. This picture of an iceberg, of course, I'm just going to focus on recruitment, and there are consistently reported obstacles to recruitment in trials. You think the hard work is getting them funded, and then the hard work really begins because then you have to recruit to them. And on the surface, everyone will say common things about the difficulties of recruitment, like there aren't any eligible patients. They were all here last year, but now you've got the trial funded, all those patients have disappeared, or all the logistical issues that go with the challenges of recruiting to trials. But what that hides, of course, below the surface is the really challenging stuff. And Jenny Donovan from Bristol University leads a team of social scientists who are innovating in this space, bringing the best of qualitative research to really get underneath the skin of trials, especially trials in trouble and especially surgical trials. And they're using interviews and observations and document analysis. It's like a little qualitative hit team that come in and swim around in your trial and help you then understand what's really going on. What's really going on at the sites that the site investigators aren't telling you? What's really going on in those consent meetings with recruiters and patients? And of course, what that highlights are all the hidden challenges that no one really is comfortable articulating. The intellectual and emotional issues that are related to these difficult things. How do you convey uncertainty and equipoise? How do you communicate randomized controlled trial terminology? How do you manage patients' preferences? And what Jenny and her team have done in a lovely series of papers is just highlight how important all that stuff is and how important it is that we elevate it and get sight of it, understand it, because then we can help build support for trial investigators and recruiters into our trials as we do them. So what will be the next game changers as I head towards the final part of my talk, as we look ahead about the next 20 years, let's say, of doing randomized trials in spine? I've talked already about these large, simple, randomized control trials and the fact that they have been a game changer. But at the same time, I'm going to criticize them a little bit because, of course, they're hugely long endeavors. Some of them take 7, 8, 10 years. And they're like juggernauts or road trains. You set them on the road and you do everything you can to keep them on the road until they reach their destination. But they are rather expensive beasts, and they are rather blunt. And of course, blunt is an important term in the field of back pain and spine, because we're all searching for how we personalize care. And these big mega trials, one might criticize them to some extent that they're not very good at testing how we personalize care for back pain or spine diseases. And so the holy grail of back pain research, we know, has been how do we better match patients to treatments in ways that ensure the right patient gets the right treatment. And so I guess I'm thinking about how we combine the mega trial concept with also stratification, which I guess is absolutely the next frontier for trials. Many of you will know that I've spent a bit of time in the stratified care space, so I'm talking about ways of working that fast-track patients to appropriate treatment to maximize treatment benefit, reduce harm, and increase healthcare efficiency. And the Start Back trial, for example, was a bit of a game changer in showing that this kind of new way of working, where we could subgroup patients using simple self-report tools, and then on the right, we could use those subgroups and allocate them and match them to different types of treatment, and then in that way stratify care and improve outcomes and reduce costs. And through a whole series of studies where we validated the approach, did a pilot trial, did a big randomized trial of 852 patients, and then we did an impact analysis study. We were able to show through the whole program of research that took over 10 years that this new way of working is at least a sensible approach in the NHS. And that approach is now recommended in the NICE guidelines and published widely across the world in many other guidelines and recommended. And it's embedded now in our UK National Low Back Pain Pathway, and it's now being tested around the world. But as we head towards more stratified care trials, whether they be about Start Back or any other method of stratification, again, just a bit of a note of caution that we do need more stratified care trials, but we better learn about the ones that have already happened. And what I would say really strongly is we need to attend to intervention fidelity in stratified care trials. These are complex interventions, and they have at least two components. We're trying to routinely subgroup patients so that every patient is subgrouped or stratified, and we know what strata or subgroup they're in. And then we need to ensure that they're offered and receive the matched treatment. And essentially what that means is if we're going to subgroup people and stratify them, we need to do something differently about their clinical care. And the trial needs to have enough adequate intervention potency to make it plausible that testing the stratified care model might show benefit. And I and others have just recently published an editorial on this where we've looked around the world at stratified care trials in back pain and begun to think about what are the early lessons already that we're learning? And hands down, I would say, don't rush to do a big stratified care trial until you've worked out how to get intervention fidelity. But there's lots of other things here about these big juggernauts of trials. They often fail to recruit the number needed. There's long timelines. Only 30 to 40% are positive trials, and by the time the results are known, practice may have moved on. And in large part, the trials that we've been doing so far are what we'd call intervention focused. They're focused on answering the question about that intervention versus a comparison. And that means that multiple randomized trials are needed to evaluate other interventions. And so the next big game changer is thinking about how do we design trials that can ask and answer many questions in the one trial. But look, before I do that, and I know I'm running a little bit out of time, so I'm just going to acknowledge that so Paul doesn't get too worried. I want you to think about this hypothetical trial, and I want you to either think about being a clinician who's recruiting to this trial, a funder who's funding the trial, or a patient who's in the trial. So just before I show you the details, choose one of those three roles: clinician in the trial, funder of the trial, or patient. And think about that as you see what I'm going to present. So here's a new study. It's called Top Star, and it's a new big RCT, and it's typically on an 8 to 10-year timeline. It's comparing treatments A versus B for a spine condition that doesn't matter for this example. In year one, we do all the ideation, we get the team in place, we get the grant developed, we submit it, then we wait. And in this example, for the purposes of this, funding success first time, which of course rarely happens, but we get the funding in year 2 or 3, and we get $1.5 million for the trial. It needs 720 patients, and the total funding timeline is 5 years, which is about the maximum that one can get funding in most of our schemes. It takes 8 months to set up, which is very optimistic because it usually takes longer, but we've got to think about sites, databases, regulatory approvals, hurdles, all of the things that it needs in setup phase. It takes 24 months to recruit and 18 months to follow up, 2 months to get all the data chased, and 6 months to analyse. And I've built in a really leisurely 2 months contingency plan. And the results are submitted for publication in year 7, and they're published in year 8. So what are you thinking if you're a clinician recruiting in this trial? This is the time for audience participation. Say it again. I can't hear you. Say it again. It's taking too long, yeah. If I was a clinician, I've lost interest. I'm off doing something else. What about if you're a funder? Who took the funding role? It's not working, is it? But at the very least, you'd be wanting to know how this is tracking, and perhaps you would have wanted some interim analyses and reassurance it's on track and all sorts of things, because it's a very expensive trial. What about if you're a patient in this trial? The sad thing about this is if you're a patient in this trial, you know absolutely nothing, perhaps apart from getting maybe some newsletters about how the trial is tracking. The really sad thing is that, let's say it needed 720 patients. Let's say your number of patients 719. The sad fact about this trial is that your patient number 719 and the care that you get in this trial is in no way informed by the data from the previous 718 patients. And so this, I think, is where we're really headed into the sort of next frontier of innovation. And that's building in innovation into the traditional very linear model. So instead of just design, conduct, analyze, we'll be building in review and adaptation loops. And we're seeing this happening in other fields. We've been doing a little bit all around the fringes of improvements in adaptation, which I've put on this slide, and they're all very welcome. But the really important stuff in terms of game-changing innovation is coming in the form of these adaptive platform trials. They're in prostate cancer. Stampede was a beautiful example, which I'll quickly get to the idea of it, which is that instead of stopping and starting, it's a bit like a train. It stops at the platform and it lets some carriages off, and then it adds some new carriages. So some treatments get dropped based on interim analyses, and new treatments can be added, and the trial keeps going. And Stampede has now had 11 randomized comparisons with no stopping and starting, and they reckon that the equivalent trial in 2-arm trial designs in sequence, the way we would usually have done it, would have taken 40 years. So these are the step change trials that are really coming, these adaptive trial designs, whether you call them MAMS trials, adaptive platform trials. But there's also further innovation in things like speed of processes, faster delivery, all without compromising data integrity. The NIHR, the big funder in the UK, the NIH in the US, and the NHMRC are all beginning to fund these trials, albeit in other areas at the moment. These master protocol trials are already happening in infectious diseases, cancers, and others. As far as I can see, not yet in spine and back pain. But these hold great promise for our field. Another example, of course, from COVID is the recovery trial. And again, I don't work for COVID. and that dexamethasone was helpful for reducing deaths by a third in the sickest patients. This trial is still going, 48,000 patients globally, 10 results so far, without stopping and starting. These are game-changing new designs. So just to finish, where are we headed in the next 20 years of RCTs and back pain and spine? I don't have a crystal ball, but this is what I would predict, that we will be expected to offer greater quality and greater efficiency through design. There'll be greater focus on the questions that need answering. There'll be many more pilots and feasibility studies, but fewer and higher quality, larger randomized trials. Adaptations will be being built in from the design phase, and those adaptations could take many forms. But the whole idea is to deliver greater quality and greater efficiency to get to the answers faster. I've just chosen one example as I looked for innovative back pain randomized controlled trials, and I'm going to just dwell on this one that has literally just published its protocol. It's called Scepter, and it's from the US. And it's a sequential RCT of stepped care with 2 randomizations. It's a mega trial with over 2,500 patients from 20 centers. And the whole idea is that people start with some treatments. They then build in interim analyses formally into the trial design. And patients who are not doing well at interim analyses are stepped up to the next layer of treatments and so on. This type of trial, I reckon, is where we're headed in the back pain field. I don't know if any of the authors are in the audience, but well done for getting this trial off the ground. It looks truly innovative. There are many other innovations that aren't limited to design that I've already mentioned, but they also need work. Like, why are we still focusing on a single primary outcome for some of these trials? What's the pre-trial information we need, particularly in terms of health economics, to justify to the funders the costs of these trials? What's the focused qualitative research that we can build in to ensure the trial recruits to target? And how do we crucially use routinely collected data better and more efficiently in future? And how do we get greater data sharing? So this is my last slide, and I guess it's a little bit of a call to action for those of you who are involved in randomized controlled trials or thinking of getting involved in randomized controlled trials. I'd ask you to think about the research waste that I mentioned of collectively over 13,000 randomized controlled trials in 55 years, and still we're uncertain about what we're doing. Think more about how we can do some team science in the business of high-quality randomized controlled trials within our countries and even across countries, ultimately so that the quality and efficiency of these trials changes and improves over time. Thank you very much for your attention.
Thank you, Nadine. That was brilliant. And we have 5 minutes and 40 seconds available for some questions. And so if there are people who'd like to answer some questions or probe Nadine's diverse knowledge of clinical trials design, please do feel free to ask. I have one to start with, and that is, what do you see are the key barriers that we will have to overcome to design and implement the next or the first big adaptive trial in back pain?
Oh, there are many. There are many challenges. I guess, given that there aren't any at the moment, and you'll probably smile, but because we've had some of these conversations a little bit already, but given there aren't any adaptive platform trials yet in the field of spine or back pain, I would suggest we walk first and then run. So I would suggest that a good way into the adaptive trial field would be through things that have a clear start and end, and are on the simple end of adaptive trials, even though they're not simple, which would be something like a MAMS design, a multi-arm, multi-stage trial, where you offer the funder a finite funding envelope with a beginning and an end, and that will reassure the funder that there is a beginning and an end, and it will also build confidence in your trial team and your statistical capability in your trial team and your clinicians in your trial, that they can begin to get involved in adaptive trials in back pain and in spine. That would be a good way in, I think, because what we're finding in these other fields like cancer and infectious diseases is that's how they started, before they build really the big platform that never stops. Unless, of course, there's a pandemic, in spine and back pain, in which case, great, we'll be there.
Thanks.
Yep.
So,
David Wong from Denver, and former associate editor for the journal Bone and Joint Surgery. In terms of reviewing these things, I got to say the two big things we run into in terms of bias, and the editor-in-chief of the European Spine Journal is sitting right behind me here, so he's probably got the even worse situation than mine. But A, intent to treat and as treated analysis for people, we think that you have to report both ways. And a lot of papers aren't. You can comment on that. And the other thing is, in surgical trials, a lot of the times the entire population is not randomized. And whether that's the SPORT trial in the US or the old Weber trial from Norway, they operated on all the worst patients and then took the group underneath that and randomized them. Is that not inherently putting a bias against surgery?
Well, let's take the first question, which was this issue of whether we analyze as we randomize and whether we also need an as-treated analysis. So in the trials that I've done, look, I've tended to do both, but the analyze as randomized has always been the primary analysis, and you know that the trial is strung up or laid down based on the answer to that, but then building in a sensitivity analysis that's often either not, increasingly not an as-treated, because of the bias of an as-treated analysis, and I'm not a statistician, so I won't begin to go into even the complexities of that, but increasingly moving away from as-treated analysis and towards things like case analysis, which statisticians can help with to try to reduce the bias. Because, of course, again, once you start doing an as-treated analysis, you've lost your protected comparison. So the statisticians are concerned about that, and they're innovating methodological ways to overcome that. So my personal approach has been to do both, but always to place the intention to treat analysis as the core answer, but then help us fully understand the results by also doing either a per protocol analysis or a case analysis. In terms of I can't comment on the SPORT trial. I wouldn't begin to even try to recall all the details of the SPORT trial. But I suppose what I would say is to try to overcome the criticism that you're placing on trials that have done that. I would say that some of what I've covered comes into play. If we're going to do a really important trial, it's so important to try to get everyone who is eligible in the trial. And maybe some of the methods that I've mentioned can overcome some of the really hard stuff around clinician equipoise, how the trials are being explained to patients by the people recruiting. You know, I think we need to do better. We need to try to get, if we're going to invest in a big trial, it's a really game-changing trial, important trial. We all need to work together to try to ensure that we get as many people who are eligible into it so that the results are generalizable.
Yeah, I think part of the problem is how it's presented by the media, too.
Oh, yes.
Because if it's a biased trial to begin with, the results necessarily aren't the thing. And the Weber study being a perfect example where Booth presented at this meeting a number of years ago, doing both the treated and the intent to treat analysis, that the results were the reverse from each one. So how can you draw conclusions?
Yeah.
we have time for one brief question, Dino, please.
Okay. Thank you very much for your this very eloquent presentation. And I think you hit the nail on the head in terms of research waste, and trials can take a long time, they can be costly, manpower is an issue, et cetera, et cetera. What are your thoughts about the potential for the virtual clinical trial platform? In other words, like these in silico computer modeling simulation possibilities to somehow offset or some of these concerns that the current situation with clinical trials present to us.
Yeah, look, I'm open to all potential innovative ideas. I guess in future, wouldn't it be lovely if we don't have to do randomized trials where every patient is in a registry or on an IEMR system with really good data for every patient, where we then might be in a situation where randomized control trials are much less needed than they are now, and we could run lots of great data analysis with the new causal inference methods that are coming from the statisticians, that some argue will replace randomized control trials in future, and modelling would be part of that. So modelling data sets as we move forward. So yes, I'm all for those innovations, but we're certainly not there yet, is what I would say. And but all innovation towards that, I think, would be very welcome. So I guess that's my very diplomatic way of saying yes, but we're not there yet.
Right, thank you.
Okay, well, please join with me in thanking Nadine for that spectacular presentation.